of the class who's not here. We're going to start our vocab lessons today, and we're not going to do, Ray says hi. We're not going to do all of them along the line, but something happened. Some of your students in my class removed some of my pages from before.
We did not.
Oh, they definitely did. Because my first page of terms seems to be missing from my document.
Wait, can you tell us when we have to write stuff down?
Yes, I can. So I'm going to start a new document here, because this document is messed up. I will not inform you as to who it was.
We'll know.
Oh, you'll know.
Wait, what did someone do?
Someone was playing around with my smartboard before I started, and they accidentally deleted all my initial pages we were working on. So that's okay. We're going to bring up a new document right here. We're going to go to our first page of notes, of vocab terms. All vocab terms are for the first day. And the very first term is independent variable. Anyone know what an independent variable is?
Why?
Incorrect. Independent variable is the x-axis.
Yeah.
Right now, Billy.
Will just got something wrong.
Yeah, I'm
And it does not
They know you'll read.
depend on anything. And you think of it this way,
No man.
an independent person, you know that independent guy, right? He rides that motorcycle. Look at that motorcycle. Okay, mine turned into a hover round. Look, it did. It looked like a hover round. It looked exactly like a hover round. And the independent variable, if you move your hover round, you go horizontally, it moves across the x-axis right there. Your dependent variable is your y-axis.
That's the y-axis.
Yep. And it depends on x-axis. It means whatever's on the x-axis determines what that variable is. Our most common independent variable, most common independent variable is time. And time will determine everything else that's going on there. So we got those two down? Awesome. We're only going to do about 10 words today. Domain. Anyone know what the domain is?
Your ex.
Yeah,
It goes alphabetically.
X.
They're the x values from lowest to highest.
Is the final just gonna be like a bunch of?
It's three parts. The first part is part multiple choice,
It's all
and
definitions.
then part fill in. Yes, the first day is just definitions. It's just this packet.
Oh,
So the day beforehand, guess what you're gonna study? Just this packet. That's it. The range are the y values, and that's lowest to highest. If you have no highest value, then you can just say your highest value is infinity, with a little infinity sign on it. Asymptote. Anyone know what an asymptote is?
God.
It's a
Close to
value.
close but never touches.
Not necessarily, but you're right. You're pretty much right.
Oh God.
It's a value you
Touches or
approach,
something.
but you never get to.
It's well, ready for this? Pretty much right again, but I'm going to change the definition slightly. It is a line you infinitely
Closer to.
approach. And I'm going to use the word approach. Get closer to is not a bad thing, but Ray, in the past, she's 100% right. I'm going to draw a picture of one here so we have it. A normal asymptote, I'll draw 3 asymptotes. One of them, asymptotes would look like that along the curve right there. It gets infinitely close to the y-axis. It gets infinitely close to the next axis. But the two never, the magic word is, they do not coincide. I know, and I'm intentionally taking that away. Up till now, the word touch was fine, but now we're going to say coincide because there's another type of asymptote, and I'm going to draw a picture of it. Oh, I'm going to draw it in green. This is an asymptote.
Ah.
It's never straight.
So it's a sinusoidal asymptote because I'm going up and past the curve, but I'm always getting closer and closer and closer to the curve. If these bumps were the same size, it wouldn't be an asymptote.
That's crazy.
But I'm getting closer and closer and closer to that curve. I'm passing over it, but they're never going to coincide. They're never going to fall into line and be in sync with each other.
Right.
It's just not going to happen. Got those words down. We don't got a lot more to do. We're not going to do a ton today. Just going to do a couple of them.
Okay.
But he's got some.
I just zoned out for like the last 5 minutes.
Two terms you may have talked about in other classes. We talked about very early in the year. Slow down, slow down. Ray, do you know the difference between interpolation and extrapolation?
Right.
He's okay. He's writing. He's not being bad.
I'm gonna write defend because that's what it looks like.
Defending.
If I go too fast, let me know. I'm going to highlight inter, and I'm going to highlight extra. Also, if anyone falls behind, every day we do these, I'm recording them and posting the video, so you can always go get what you missed if you kind of fall behind. Ray, do you know what the word inter means? He's right. We'll let him go.
What did you say?
Billy, you know what the word inter means?
Inside of.
Inside. If I asked Ray, I didn't get an answer, but I asked Billy. I got the answer. It means inside. And what does extra mean?
Outside.
What do you need?
Outside.
Like an exoskeleton.
Correct. Or Interstellar, which I'm happy to be watching right now.
Oh,
Great
that's
movie.
a great movie.
Great movie. Interpolation
Or intercolonic.
is, never mind, Ray, we're going to finish our thing right here. We're recording, Ray. Interpolation is looking for values. Inside data. And I'll draw a picture to help out. And extrapolation is looking for values.
Looking for values inside
Data. And then looking for values outside data. And an example of each would be the following. I'm going to draw a little graph. Okay, I'm going to put some points on here. Okay, this is 1, and this is 5.
This sucks.
I'm going to draw a line. Let's say I ask you to estimate the value of that graph, to find the value on that graph, when x is equal to 3. Why is that interpolation?
Because it's in between, yeah.
It's inside that set of data right there. It's inside that set of data right there. But Ray, sometimes we have a different set of numbers, and sometimes we have values. 1, 2, 3, 5, 7, 10, 9, 14.
Yeah, I don't need Mr. Brigham!
I'm recording.
Oh, you are?
Yeah.
Oh, shoot.
Let's say I gave you this set of data, and I asked you to guess what the value of the data was when x was 19. Why is this one outside?
Because it's outside of
Not
the...
in the given data.
It's outside the set of values I'm looking at right here. We have just a few more to do. We're going to stop at, whoa, screen, come on back.
Doesn't like us.
Can we stop right
No, we're stopping at inverse variation. There we go. The next term is argument. Aiden, what's an argument?
now? Oh,
Something that happens with
something
mom.
you have with another person.
That's right. This is something you have between another person. There's always something that starts that argument, right? There's always something that makes an argument kind of happen.
Mean person.
Okay, the argument of a function is the input. The big times we use that are on things like this. If I write down the sine of x plus 5, guess what the argument of sine is?
X plus 5.
X plus 5. It's what I'm putting into the equation. If I wrote down the ln of a chicken head, or the whole chicken, we'll do the whole chicken, plus a star,
And the fish.
It would be chicken star.
it would be
What the heck is that?
full chicken plus star would be the input. Whatever's in that set of parentheses is the argument of the particular function. Now there's two important functions we normally talk about, direct variation and indirect variation. You guys know the difference between those?
Wait, is the x and the 5 the input or just the x?
Whatever's in the parentheses. Whatever's in the parentheses is the input. Anything that goes in is the argument. So if you see in the parentheses x plus 5, that's your argument for sine. Direct variation, as x gets,
Bigger, y gets bigger.
but what happens if x gets smaller?
Y gets
Smaller, they're known as direct variation because they follow the same pattern. And I'm going to write down what the actual equation for that is. Y equals kx. Y equals kx. And that just means as x gets bigger, y gets bigger, but that k is like the ratio that does the two.
What does it actually stand for, K?
Constant. So if I made that the number 3, right, it determines how they go together. And the last term for today, Aiden, is inverse variation. If direct, as x gets bigger, y gets bigger, Aiden, what do you think happens on indirect variation?
They get small.
As x gets bigger,
Ow.
It-
Why get small?
y gets smaller.
Hey,
And as x gets smaller,
why get big?
y gets bigger. The equation for that is y equals k over x. It shows an inverse relationship. And just so we know,
Our perfect done for the day.
almost, direct variations are lines, and inverse variations look like this with asymptotes. Because this shows as x gets bigger, y gets smaller. As x gets smaller, y gets bigger. So there's our first set of terms for today. That's kind of the first grouping of terms. I'll save the video and then we'll work on it more tomorrow.